Welcome back everyone to the Hello World Guide. This is another episode of the Android game development series, and in this video we are going to move forward with our OpenGL renderer by understanding some more OpenGL concepts. Right now we are specifying our colors in the vertices. Let's say I don't want to do that, but instead want the whole shape to have one color. So I'm going to remove those from the vertices, and then I'm going to remove this other attribute as well at index 1, and then I'm going to change the stripe to represent the size of our vertex now, which is 2 floats. And then we can go up here and we can remove this attribute that we are taking in, and we can also remove this color. And then for example we can hard code a color in here, for example yellow. Yellow we won't really see because our background is also yellow, so we can change it to a different color. But this is actually hard coded in the shader. We will also need to remove this assignment statement, and once we do that we can go ahead and try to run this, and you should see that we get the color that we specified here. But the problem is that we have hard coded this color. We want this color to be able to change this color from our main program, and that's where uniforms come in. So a uniform variable is like a variable that we can which is present in the shader, but we can modify it from our main program. So we are going to declare a uniform variable of type vec3, which we are going to call color, and this we can modify for each shape as well as for each frame, or we can just set it once in the beginning. We are going to use this in our shader to actually specify the color that we are outputting, and then inside of our do frame function, or actually we can do it once at the start. Since we are not changing it, we must use the program before we set any uniforms. Then we can use the GL uniform family of functions to specify what kind of data we need to put. We can use GL uniform 3 because our vector consists of 3 floats, so we are going to use 3f. You can also use 3fv to specify an array or a pointer, but we are going to use just the plain 3f function. And the first argument is the location. Now we only know the name, and to get the location we are going to use the GL get uniform function. We are going to pass it our program as well as the name of the uniform. It will return us the index or the location of that uniform. And then the next arguments are going to be just the xyz or the RGB of that vector. We are going to specify the same color here, and I can go ahead and try to run this, and you should be able to see that it still works correctly. So you can see we get the color here, and I can change this to another color. For example, I can set this to white, and if I do that, you should be able to see that it changes to white now. And all of this works nicely, and we can actually change this. If we want to draw multiple triangles, we can draw multiple triangles, and we can change the uniform to draw each one of them with a different color. Now let's say that I don't want to draw just a triangle, but I want to draw a rectangle. To draw a rectangle in OpenGL, you can either draw points or lines or triangles or different variations of lines or triangles. But if you want to draw, for example, a sphere, then we'll need to specify the sphere as 2 triangles. Basically any polygon can be represented as a bunch of triangles, and to specify our sphere we'll need 2 triangles. So I'm going to go up here. I'm going to change the top left corner to be at the left side instead of in the center, and the x-axis is going to be -5. And then I'm going to copy this, and I'm going to basically keep this vertex. This is going to represent our second triangle of the sphere now, and we're going to remove this one. I'm going to copy this vertex so that we can specify positive x for it to represent the other side of our rectangle or sphere. And then I can change the count of the vertex arrays to 6 so that we can draw 6 vertices. And if I were to run this right now, you'd see that inside of here we get a white rectangle. This is actually a sphere, but it's a rectangle because of normalized device coordinates. Now one thing that you might notice is that in our vertices, our rectangle actually consists of 4 vertices, so we are basically wasting 2 vertices, and we are also wasting more operations on those vertices, which is not something we want to do. So to fix this, we can use something called index drawing. What this means is that we will create an array of indices into this vertex array, and that will allow us to basically reuse vertices without any extra not any extra cost, but without too much extra cost. So we can go under indices, and we can specify the indices, 3 indices of our first triangle in the vertices array. Then we can specify the indices of the second triangle, and then we can remove the unused vertices here. And to upload this data, we'll need an EBO or an element buffer object, and this is just a buffer that stores the indices. So we'll use GL buffers to create these buffers, and after we have created the buffers, we'll bind it, and the target that we want to bind this buffer to is the GL element array buffer target. And after binding the buffer, we can use GL buffer data to upload the data to this buffer, and this is going to be just our indices array. We are going to just upload the data to this buffer. And once we have done that, we can go down to where we are doing our GL draw vertex arrays, and instead of doing that, we can first bind our element array buffer because that must be bound for index drawing. So we can go and say GL bind buffer, and we can use GL element array buffer as the target. And once we have bound that, we can, instead of using GL draw arrays, we can use another function called GL draw elements. Now this takes mode as the argument, the second is the number of indices, the third is the type of indices. Since we are using uint32, we are going to say GL unsigned int, and for uint16 you will use GL unsigned short, for uint8 GL unsigned byte. But we are going to say GL unsigned int here, and then for the indices pointer we are going to pass null. Since our buffer is bound, this represents the offset. Null just means we want to start from the beginning. You can pass the indices here directly, but that's less efficient. So if I were to run this, you can see that we now get a white rectangle on our screen that looks perfectly, and we do that using only 4 vertices, and we repeat the vertices using an indices array. Anyways guys, this is going to be pretty much it for this video. This was kind of a short one because I just wanted to get some concepts cleared up, and in the next video we'll finally get to transformations and how to have a coordinate system according to our preferences, and how to actually move our shapes that we are drawing. So I'll see you in the next one. Make sure to like and subscribe and share this video with other people as well, and bye.